All right, so first of all, let's talk about what is actually a limit. Okay, limit. For us to look at a limit, it's probably better for us to do some calculation, which is so-called numerical approach. So numerical approach to limits. Okay, when we say numerical approach, that means we're using numbers for calculation. Okay, so the calculation process will help you to understand what this function is doing when it comes to a certain point. So example 1. I'm going to write down a function which is very easy. Okay, so let function f of x be x plus 1. And let us compute the function f of x. Compute the value of f of x, right? Of course, we're referring to the value of f of x as the x takes value. All right, next is the key thing. Close to 2. Do you see I intentionally changed the color to close to 2? What does that mean? X is taking value close to 2. Any value you can think of that is close to 2. Jordan, can you give me a value for x that is close to 2? You're muted. I can't hear you. There you go.
Sorry, I had to find my cursor. 1.5 is close to 2.
Huh? Point and a half? Say it again.
1.5?
Oh, 1.5. Okay. Jordan said x equals 1.5. Oh, by the way, let's do this. Can you guys go to your RingCentral and do you see view option? Do you see view option, guys? There's no view option? Let me see. Somewhere there should be one option for you to do annotate. Can some of you guys explore the ones from your RingCentral and find out? Looks like Elijah has to find it. Can you share
it's
what
at
the
the
rest
top
of it?
It's at the top of the screen.
Do you see annotate? If you have found it annotate, can you try to annotate on my screen? Can you write down a value for x that you think is close to 2? I see Michaela's 1. Okay, I see Katie's 1.9. Keep going. I see Rai 1.8. Okay. I see Emma is trying to get it 1.8. Any other values? Monica 2.1. Okay, now let me emphasize one more time. It is close to 2. Oh, close to 2. Yeah, okay, close to 2. Very good. Any other value? It looks like you all picked a value that is less than 2. Can I find a value that is close to 2 but greater than 2? Right? Okay. 2.01, very good. Elijah? 2.1, good. Any other thoughts? Carson, can you annotate on a screen? And what about?
I'm trying to figure out where the annotate button is.
Okay, Monica, Daniel, have you guys found the annotate button? Michaela, Deuce. Okay, Deuce, yep, 2 point, is that 5 or 3? 2.5, okay. Carson, have you found your annotate button?
No, I don't know where it would be.
Carson.
It's a secret place it's hiding.
Yeah.
Carson, do you see that you are viewing Lena Wu's screen? Right next to that should say view options.
View options.
It's at the top. center top.
The thing is, you guys probably is in different views. So when you say view option, that
Probably.
might look
Yeah,
different.
no, my screen's, I got full screen right now. So if you put yours in
Oh.
full screen.
Okay, let me try that real quick.
I see Michaela here.
Oh, there we go. Okay, it was
There we
hidden.
go.
Just kidding.
Great, yeah, because we'll be using the annotating functions later on when I'm asking you guys to work on the screen. Okay, so
Yeah, there we go. Okay.
great. Okay, Carson, you found it?
Yeah.
Okay, there you go. It's a little harder for you to write a dot. Great, so I've seen different kinds of numbers you guys are putting there. Okay, I see these numbers like 1.9, 1.8, 1.1, 1.9, 1.9, 1.8, 1.9. This is one group. I see another group of numbers that you guys write down for 2.2, 2.5, 2.01, 2.5, and 2.1. You probably have seen that these two groups of numbers are, one group is less than 2. One group is less than 2, the other group is bigger than 2. Okay, very good. So thank you for the participation. Let me clear the screen real quick over here. All right, so what we have seen is when we say x is getting close to 2, if I draw a number line, here's my 2, right? Which is the target where it's heading to. So your x can actually getting close to the 2 in 2 different ways. Our x can approach the 2 from the left, which is those values that you have put in there that's less than 2. Our x may also approach the 2 from the other direction, which means it's bigger than 2. So we should take a look at 2 cases. Okay. So case 1, we're looking at a case study, sort of, right? Case 1 is when x approach 2 from the left. So we're going to put some notation over here. When we say x approach 2 from the left, those x's are actually smaller than 2. So we say x is approaching 2 from the left. So this is a notation. We say x approaching 2 from left. Basically, this indicates my x is smaller than 2, right? Is that good so far? Okay. So then what we're going to do is we're going to make a table, because the table helps us to organize our thinking. And in this table, we're going to put x on top as the left column. And the right column is what we are interested in. Okay. Let the function f of x be x plus 1 and compute f of x. So compute this f of x equals x plus 1. So we're computing f of x equals x plus 1. And we know this could be written as y, because f of x is just y, right? Y value. Good so far? Now, because x is less than 2, I'm going to write down the numbers you guys have putting on the screen. So x could be 1.9. Let's start from 1.8. I think there is 1.8, right? X could be 1.8, which is getting close to 2. So here's a 2. So 1.8 somewhere here, and then you go 1.9, as some of you guys have written down. We can have x even getting closer to 2. You can say 1.95. That's even closer to 2, approaching 2. Can I let it even move even closer? Of course we can. We can do 1.96, right? And even closer to 2, 1.97. And I can keep increasing the value of x as it approaches 2. So I can 1.99, 1.999, 1.9999, 1.99999. Is that close enough to 2? Right, that's very close to 2. And then you'll be finding their function value. We are observing when x moves close to 2, what happens to the y? So the y is x plus 1. So that's so easy to calculate, right? You just add 1 to the x, and that's going to be your y value. Okay, I'm going to start assigning you guys so you can work on the screen, play with the annotation, and maybe change your color, whatever. So let's go. Emma? Deuce?
Yes.
You're the first block. Elijah? Okay. Monica? This is 4th. Okay, then 5th. Daniel? 1, 2, 3, 4, 5. Yes, 6. Katie? 8, right? Michaela? Okay, Michaela. If you didn't get your assigned for this round, you'll have another chance for the second table. Don't worry. Thank you for your numbers jumping up and down on my screen. Okay, right. Thank you, Katie. Oopsie, my bad. Sorry, hold on. Keep going, keep going. Can you annotate on my screen, Michaela? Anderson?
I wasn't sure if you were gonna scroll down.
Yeah, I'm gonna scroll down. Yeah.
Okay,
Now it's scroll down, so you can annotate. Great. Keep going. I believe you can draw. You probably can also enter text sometimes. It depends on different settings. Have you finished yours, Michaela? I thought your name showed up on my screen once and then it disappeared.
Me, Michaela?
Yes, I think yours is Michaela and yours is Michaela Pierce. Is that how I differentiate between you two? Okay.
But no, I couldn't see the number at the bottom of the screen to do that.
Oh, I see what you're saying. This one, right? Is that 1.99999?
Yeah, thank you.
Okay. 1.9999. Yes. So you have 4 9s. And if you have finished your block, go ahead and complete your table on your notes as well. And can you sort of see what's the trend of this function? Where is it heading to? Okay, thank you, Michaela. Great. So you guys have completed this table. Okay, so these are different x's when x is approaching 2 from the left-hand side. And the function value will be 2.8, 2.9, 2.95, 2.96, 2.97, 2.99, 2.99, 2.99. Do you see a trend as x is approaching 2? As x approaches 2, where is this function value approaching to?
3.
Okay, yeah, it's getting more and more close to 3, right? Okay. Let me move on. I have to clear this, unfortunately. So we're getting close to, so looks like, it looks like, we can put this in wording. Okay, so it seems that as x is approaching 2 from the left, the function value y equals f of x is approaching an amount which is 3, right? Is getting close to 3. So we can actually use a mathematical notation for this. What we can do right here is we can say the limit of this function. Okay. When x is approaching 2 from the left is equal to 3. So this is the mathematical expression, which is very concise, okay, and fancy looking. This expression basically just expresses what we have just written upwards. As we're saying, basically it describes as x is approaching 2 from the left-hand side, my function y equals f of x is approaching 3. Okay, is this okay so far, guys? All right, so this is one situation, as we said, right? You can force x to approach the 2 from the left-hand side. Now let's go case 2. So case 2, as we have said, some of you guys, when you write down x is close to 2, you can do 2.1, 2.2, 2.3. So we can also say as x approach 2 from the right. Okay, we're just going to have the notation here. Will just be x approaching the 2. If you say from the right, then it's going to be 2 plus. Okay, approaching 2 from the right. Let's take a look at what's the behavior of the function. Okay, so same thing. Let's go ahead and construct a table. This table now observes the x, which is approaching 2 from the right. And we're looking at the function value y equals f of x. That is still the same function x plus 1. How is this function behaving? All right, and we have seen that if I draw a number line, here is 2, approaching 2 from the right, here's my x. So you may start from 2.5. Right, 2.5. And getting closer to the 2, so I can go to 2.3. And I can move closer, I can go to 2.2, 2.1. Here's 2.1. You can even getting closer, 2.01, 2.001, 2.0001. Is that close enough to 2? Of course, you can say I can do 2.000001, right? Okay, but this is just the trend. Okay, so now let's go ahead and calculate the function value to see what's the behavior of this function, right, as of now, when x is approaching 2 from the right. All right, I'm gonna assign Michaela Pierce. Michaela Pierce. So for the first one, okay, and then let me go Deuce for the second one. Carson for the third one. Okay. Right for the first one. 1, 2, 3, 4. Okay. Katie for the fifth one. Emma for the sixth one. And let's go Jordan for the seventh one. Go ahead and enter your value. Michaela, x plus 1. Function is x adding 1. Is it 1? Yeah, there you go. Okay. Carson, I got yours. Keep going, guys. All right, let me see. 1, 2, 3, 4, 5, 6, 7. Great. So everybody has got your function value. And once again, let's observe what happens. When x is approaching 2 from the right, which amount this function is approaching? Can you see a trend? The y is getting close to what amount, guys? What value is y getting close to 2?
2.
I heard a 2 and I heard a 3. Let's look at y. Y is approaching what amount?
3.
3. Okay, great. X is approaching 2, but y is getting close to 3. Okay, so I'm going to move down here. Okay, so we can say over here, we can say as x approaches 2 from the right, my y is approaching the 3 again. Okay. My y is approaching 3 again, right? This is the same value that y is approaching as we see in the previous case. How do we use the limit notation to write this? So this time, how do we write it? So we're going to say limit of this function f of x is 3 when x is approaching 2 from the right. Okay, so this is the conclusion when you observe this function from the perspective of x approaching 2 from the right. And these two expressions we have written down are called one-sided limit. Okay, so this limit over here, which is approaching the 2 from the left, this is called left-sided limit. Okay, so the side, the limit from the left side. And for the other box, okay, this time x is approaching 2 from the right, so this is called right-sided limit. Okay, so overall, the limit is basically the trend. Okay, the limit is the trend of the function when x is doing some is moving towards a certain point. Okay, is that clear so far? Okay, so over next, we're going to look at another example. And over here, we're going to actually look at this from another trend. Before we do that, let's put a note here. Okay. So note, basically, we said if limit of function f of x, x approaching an amount, say c, from the left equals L, the L referring to left-sided limit. And limit f of x when x is c approaching from the right equals to R. R referring to right-sided limit. Okay, so left side limit being L and right-sided limit equals to R. And if these one-sided limit, okay, left side and right side limit, L and R, if they happen to match each other, L equals R. So which means the function is approaching the same amount, whether x approaches c from the left or x approaches c from the right. Then we can just make a conclusion saying limit of function f of x, x approaches c overall. Okay, you probably have noticed that the change of this notation. X approaches c without putting plus or minus sign in the upper right corner equals to the limit L. And when you see this notation, this is referring to two-sided limit. Okay, so the two-sided limit is when you have left-sided limit matches the right-sided limit. And then you can say, well, these two, they match. So I can just say, overall, the function, limit of function f of x, whether x approaches xc from left or right, it equals to the limit r, limit L, which is the same as r, right? Does that make sense? Okay. Now, this is the perspective if we just do from the numerical approach, if we just calculate the amount, right? But sometimes calculating might be tedious. If it's too tedious or not easy to perform, or suppose you don't have the calculator with you at all, right? What you can do is you can look at its graph, okay? So second is called the graphic approach to limits. Okay. To limits. So let's take a look at the graphs. Maybe the graph can tell us more about the function itself and its behavior. Okay. And we're going to revisit the same example as we did before. So revisit example, which is x is getting close to 2 and y equals f of x equals x plus 1. Okay, approaching where? Okay. As we have mentioned, we should look at two sides. First is when x is approaching 2 from the left, and second case will be x approaches 2 from the right. Good so far? Okay. Usually look at the left side limit and right side limit. And I'm going to actually sketch the graph y equals x plus 1, right? Because if you want to look at the graph, you need to have its graph. What's the graph of this y equals x plus 1? Is that a parabola? Is that a circle? Is that a straight line? Or is that a point? Y equals x plus 1.
Straight line.
It's a straight line. Very good. It's a straight line. And what is the slope?
1.
Yeah, mx plus b. If you guys still remember pre-calculus, y equals mx plus b. So over here, slope will be 1, and the y-intercept will be 1 as well. So m equals 1, and then b equals 1, right? Let's go ahead and sketch this line. So go ahead, sketch this line. It intersects the y-axis at 1. And the slope is 1, which means the rise over run equals 1. Okay, so it should have x-intercept at -1. And the line should be going upwards like this. Right? Okay, now let's find x equals to 2. Can you find the 2 on your x-axis? Over here is 1, here's 2, right? Okay, I should probably extend this a little bit longer, but anyway, this is only for x approaching 2 from the left-hand side. So let's look at this 2. 2 is the value x is getting close to, okay, approaching. So let me show x is approaching 2. So this is the way for x, heading close to 2. Okay. So that means the points are going to be these points, right? These are going to be my x points. They are heading this way. What happens to the corresponding point actually on the graph? Guys, for this x, it corresponds to this point. For this x, it corresponds to this point. For this x, it corresponds to this point, right? So those points, are they moving upwards on the line, on the actual line? When X is heading this direction, are my points actually moving upwards? Is it going this trend? Let me use another color, guys, over here. Oopsie, my line just disappeared. Go back. I'm going to show you this. As X is going to the right, getting close to 2, my point should be going upwards on the line, right? Does that make sense? If you see the graph? But even though they're going up, they can't go all the way up, right? They should be getting close to a point. Where is that point that they're getting close to? Can somebody annotate the point on my graph? They can't go all the way up. They can't keep going. They'll have to stop at a certain point. Let me give you a hint. For this point too, it actually matches a point here, right? So if my X is actually going this way, then the real point is heading this direction. And they should be heading close to the pink dot on the line. Is that clear, guys? Okay. What is the y coordinate of this pink dot? Where does the pink dot match on the y-axis? Remember, this line is y equals x plus 1. So if x equals to 2, this y actually equals to 3, right? Are you guys confused, Jordan? Okay, so as you can see, all those dots are moving upwards and getting close to this pink dot, whose y values are actually 3. So that means their y values are increasing and getting close to 3. So these y's are moving upwards and getting close to 3. Is that consistent to what we had when we do the numerical approach? So limit of this y, okay, as x approaches 2 from the left will be 3. Let me zoom in a little bit so you guys can see. Let me just guide you through of the entire process that we have taken here. First of all, we understand x is approaching 2 from the left. So those x are heading to the right, getting close to 2. At the same time, we can see the corresponding points on the line are moving upwards, which means their y values are going up as well, but they would be stopping at the point 3, right? So we set limit of y equal to 3. Okay, so with this same rationale, can we try to use the graph of y equals x plus 1 to figure out of x, the limit of the function when x is approaching 2 from the right? Same graph, right? 0, 1, 2. And for this 2, the point will be at 3. And this time, my x is approaching 2 from the right. So how do we draw those arrows? That can take us to think about the limit. Any thoughts? Any thoughts over here? First of all, look at your x. X should be going this way. Thank you, Jordan. So the points are moving downwards along this line. What happened to the y's? What happened to the y? What's the behavior of the y's? Yeah, Elijah, I see the two big, big arrow. Y's are verticals, right? Are they going up or going down on the y-axis? Yes, thank you, Elijah. Yes, for the y points, okay, for the y value, they're actually going downward, okay. Even though they're going downward, but they are getting close to this dot 3, right? So the y is still getting close to 3. So limit of this y as x approaches 2 from the right equals 3. This is the argument if we see the actual graph, okay? So with the graph given, you can always figure out what's the limit of the function when x is heading to a specific direction. Any questions before we move on to exercises? Okay, if you have finished your drawing, then let's go ahead and move on to exercises. I'm going to give you one example here now for you to think about. So exercise. This time I'm going to give you a tricky one here. Okay, I'm going to draw a graph. The graph actually has several pieces. Okay. The one piece looks like this. It starts at 1. Here's 1. Here is, that looks like 0.8-ish. This is open dot. Okay. And then I'm going to have a second part. The second part goes like this. It has an open hole at 0.5, 0.4. And the second part is even more curlier, like this. See that? So the entire graph actually has two pieces. One is from -infinity all the way up to 0.5, and the other part is from 1 to infinity. Okay, is that clear? And there is another point, which is here. There is a solid point at 0.5, 0.8. Okay, Mr. Daniel. Hey, Daniel. Oh, you're still there. Great. I was wondering if you have dozed off. Okay, so for this question, I'm going to ask you guys to figure out the following limit. What is the limit? This is function f, okay? Of this function f of x as x approaches 1 from the right. What is the limit of this function f of x? Okay. Let me add another piece here. I want to make it more complicated. So let's do this. Another piece looking like this. Between 0.5 and 1, do you see a small line segment? Let's figure out what's the limit of function f of x as x is approaching 1 from the left. And at the same time, I want you guys to think about what is the limit of function f of x as x approaches 0.5 from the left. And what is the limit of this function as x approaches 0.5 from the right? Also, I'm going to ask you, what is the function value at 1 and what is the function value at 0.5 based on the graph I have sketched? I'm going to make it smaller so you guys can see the entire question. This might be a little bit tricky. Just try to remember drawing the arrows. Do you want to write anything, Daniel? If you have got something, go ahead and put it on the screen.
No, I just forgot to turn off my thing.
Okay, you don't have to turn it off. If you have finished all the questions, you may send me your answer in the chat. If you don't want to send to everyone, you can send to me privately, and I can tell you whether you got it right or wrong. Okay, by the way, let me label these as A, B, C, D, F. A, B, C, D, E, F. If you have anything that you already done, you can send them to me privately. Let me check your answer. Anyone has finished part A? F of 1 equals to, what is f of 1? Uh-huh. Thank you, Daniel. Thank you, Jordan. Yep, f of 1 will just be 0.8. What we're doing is for f of 1, we're looking for x equals 1, right? So x equals 1 is here. And we're looking for any solid point corresponding to x equals 1. Solid point will be this one. This is the solid point. The y value will be 0.8. So f of 1 will be 0.8. Okay, question B. What is the limit of the function as x approaches 1 from the right? From the right. Jordan, I see your answer. That is correct. Anybody want to send me your answer? I can check it. Elijah? Did you look at the y coordinate? You're going to read the y coordinate, okay? Daniel, why it's 0.9? Where did you get the 0.9? There's only 0.4 and 0.8. yes, Elijah this time is correct. Very good. Carson, you got 0.8. That is good as well. Okay. Yes, so in this case, guys, what we need to do is, yes, right, it's 220. Let me finish this one and we're done. Okay. So when x is approaching 1 from the right, we should do drawing x is heading this way, and the graph will actually be heading this way, right? And the y value is going to be going downwards, and the y values are getting close to this 0.8. So the right-sided limit will be 0.8. Okay? And next time we'll be continuing the C, D, E, F. Okay, and you can send me the answer again, and I can check if that's correct or wrong. Okay. Any questions before we finish our class today? Nope. Okay, then I'm going to uploading the homework later on onto the my courses, and you go ahead and work on your problems. Okay. See you next time. All right. I have. Is that Jask? Think. Are you for next class here?
I think so.
Okay, yes.
What else did you say?
So you can stay here. Yes.
Okay, I was like,
yeah, the
did I
other
miss
them. No,
Okay,
you
sorry,
don't miss any.
sorry,
You're
sorry.
early. Okay, yes.